For as long as we've been human, we've looked up at the night sky and wondered, what is all that stuff out there? How does it work? And where do we fit into the whole grand cosmic scheme? Well, this is the story of 5 incredible thinkers who dared to find the answers, each one building on what the last discovered. Let's follow this amazing story.
This quote from Isaac Newton, it's just perfect, right? It gets to the very heart of how science actually works. It's not really about one lone genius having a sudden eureka moment out of nowhere, no. It's more like a legacy, an inheritance of knowledge passed down through time. Every new discovery is only possible because of the hard work done by those who came before.
So that's the big question, isn't it? Who were these giants? How did they connect? We're going to dig into that and see exactly how each piece of this giant cosmic puzzle was carefully and sometimes painfully put into place.
And to help us wrap our heads around it all, let's imagine it as a great relay race. A race that lasts for centuries, where the prize isn't a gold medal, but a deeper understanding of our universe. And with each leg, a new runner grabs the baton of discovery and takes us all a little bit closer to the truth. Our race starts in the 16th century with our first runner, a Polish astronomer named Nicholas Copernicus. And boy, did he fire the starting pistol with a bang. He kicked off a revolution that would totally change how we see everything. Okay, so for more than 1,000 years, the world just knew how the universe worked. It was the geocentric model. Earth was at the center, unmoving, and everything, the sun, the moon, the planets, revolved around us. It was complicated, sure, with all these weird circles on circles called epicycles, but it mostly worked for predicting where planets would be. But then Copernicus comes along and suggests something that sounded completely insane. He said, what if the sun is at the center? It was so much simpler, so much more elegant, and it was an idea so dangerous it was considered heresy. And Copernicus knew just how dangerous it was. I mean, this guy was a priest himself. He was so scared of what the church, and frankly, what everyone would think, that he literally sat on this revolutionary idea for decades. He only let his book be published right as he was dying, so he never had to face the storm he knew was coming. So the first baton is passed. Copernicus gave us a brand new map of the cosmos. He told us what was happening. The Earth goes around the sun. But he didn't really have the hard proof to convince everyone. That massive job would be left for the next runner in our race.
And the baton is now in the hands of our second runner, the fiery, brilliant, and incredibly stubborn Italian astronomer Galileo Galilei. He didn't just believe Copernicus's idea, he was determined to prove it.
And he found that proof thanks to a revolutionary new gadget, the telescope. He pointed it up, and the old universe just shattered. He saw that the moon wasn't some perfect heavenly orb, it had mountains and craters, just like Earth. He saw the Milky Way wasn't a cloud, but millions and millions of individual stars. But the real knockout punch? He discovered 4 tiny moons orbiting Jupiter. This was it. This was the undeniable proof that not everything in the universe circled the Earth.
But when you go around breaking a worldview that's been in place for a millennium, you tend to make some very powerful enemies. Galileo's discoveries put him on a direct collision course with the church. After years of arguing for the sun-centered model, he was finally dragged before the Inquisition. In 1633, he was found guilty of heresy and, under the threat of torture, was forced to get on his knees and publicly deny the truth he knew in his heart. And this is where we get that amazing legend. They say that after he recanted, as he was getting up, he quietly muttered to himself, "Eppur si muove," and yet it moves. Now, we don't know if he actually said it, but it doesn't matter. The phrase perfectly captures his spirit, a man who knew the truth, even if the world wasn't ready to hear it. So Galileo passes the baton. He gave us the evidence, the visual, undeniable proof. But the new universe he'd shown us was still kind of wild and lawless. We knew the planets went around the sun, but nobody knew the exact rules that governed their elegant dance. That was the next great puzzle, waiting for our third runner.
And so enter Johannes Kepler, a German mathematician who was, let's be honest, kind of obsessed. He was driven by this deep, almost spiritual belief that there was a hidden mathematical harmony in the heavens, a kind of divine geometry, and he was going to find it. After years of just grinding away at the best astronomical data available, Kepler cracked the code. He came up with 3 laws. First, he realized planets don't move in perfect circles like everyone thought. They move in ovals or ellipses. Second, they change their speed. They move faster when they're closer to the sun and slower when they're farther away. And third, he discovered this mind-blowing mathematical link, a kind of magic ratio between how long a planet's year is and how far away it is from the sun.
And here we have the next perfect baton pass. Kepler wrote the cosmic rulebook. He described how the planets move with just breathtaking precision. But his laws were just descriptions. They didn't answer the biggest question of all. Why? What was the invisible force making all this happen? That question, the ultimate why, was about to be answered by our fourth runner, a man who would take all the work of Copernicus, Galileo, and Kepler and tie it all together into one of the single greatest accomplishments in the history of human thought: Isaac Newton. You know the story of Newton and the apple, right? Well, his true genius was realizing that the force pulling that apple to the ground was the exact same force that was holding the moon in orbit around the Earth and holding the Earth in orbit around the sun. It was universal. He called it the law of universal gravitation. And suddenly, this one single, beautiful law explained, well, pretty much everything. It explained falling apples. It explained the moon's orbit. It explained why planets follow Kepler's laws perfectly. It even explained the tides in the ocean. For the first time, the laws of physics on Earth were the same as the laws of physics in the heavens. The why had finally been answered. For more than 200 years, Newton's vision of a perfect, predictable, clockwork universe was the law of the land. His physics seemed complete, untouchable. But deep down, at its very foundation, there was an idea, the idea of absolute space and time, that was about to get a serious challenge. It was time for one final baton pass. And our final runner, he didn't just grab the baton and continue the race. He fundamentally changed our understanding of what the racetrack itself was even made of. His name, of course, was Albert Einstein. So let's back up for a second. Newton described gravity brilliantly, but he admitted he didn't know what it was. He just saw it as this mysterious force, this invisible rope that somehow reached across empty space and pulled things together.
Einstein looked at this and came up with a completely different idea, a totally revolutionary one. He said, there is no mysterious pull. Instead, big objects like our sun don't create a force. They actually bend and warp the very fabric of reality, a four-dimensional fabric he called space-time.
And this is the part that will really bake your noodle. The Earth isn't being pulled into orbit by the sun. The Earth is just moving in what it thinks is a straight line, but it's moving through the curved, warped space-time that the sun has created. Gravity isn't a force, it's just the shape of the universe. Wow, just stop and think about that journey for a second. We went from a cozy little universe with Earth sitting right at the center, to a giant clockwork machine governed by an invisible force, and finally to this bizarre, dynamic cosmos, where space and time itself can be stretched and bent. From Copernicus all the way to Einstein, every single runner in our race took that baton of knowledge and ran with it, allowing the next person to see just a little bit farther. This is it. This is how science is supposed to work. It's a great human collaboration, building on the past to invent the future. And that race, it is far from over, not by a long shot. Right now, a whole new generation of scientists are using these incredible tools, like the Hubble and James Webb telescopes, to look deeper into the universe than we ever thought possible. Which just leaves us with one final exciting question. What amazing new discoveries are waiting out there, and whose shoulders will the next giant stand on?